Hello everybody and welcome to the A-Level Physics No Waffle GCSE and No Waffle A-Level series. This is the fourth video of the electricity series, and here are the contents. Again, they will be time-stamped and it's a good resource for you to use as active recall prompts. Beginning with resistivity. What is resistivity? Resistivity, in exam terms, is a property that describes the extent to which a material opposes the flow of electric current through it. So it sounds a bit like resistance, and resistance is often depending on the situation. Something can experience more resistance at a certain situation, whereas resistivity is a very fixed property, and a material will always have a certain value of resistivity, which suggests that if a material has a higher value of resistivity, it will oppose the flow of current a lot more. As mentioned again, so a material has high resistance if it's got high resistivity, and it will oppose the flow of charge. So these materials tend to be insulators, whereas materials with low resistivity means that they will undergo lower resistance and therefore a greater flow of charge, and they are conductors. Now, resistance depends on a multitude of factors. For example, the length of the wire. For example, if you look at this diagram and animation here, you can see that in a shorter wire, there's going to be less collisions from going from point A to point B. Whereas in a longer wire going from point A to point B, the beginning to the end, there's more collisions because there's more atoms. This makes sense if you think about the corridor analogy. If you're trying to get through a short corridor, you're going to experience bumping into less people. Whereas if you're going to go through a really long corridor with lots of people, you're going to bump into so many people that you're going to end up with much less energy towards the end. Therefore, you would have experienced a lot more resistance. The second idea is the cross-sectional area of a wire. And the final factor is the resistivity of the material. So let's look at this animation, which really does highlight exactly what we mean. So hopefully here you can see a key equation. Resistance is equal to resistivity, which is shown by the symbol rho, times by the length divided by the area. So if we increase the length, as we just said, you can see that the resistance value is getting bigger, because as we said, the length of the wire that it has to travel is getting bigger. Now, if we were to increase the cross-sectional area, then let's think about what would happen. If you were to make a corridor smaller, that means you would only collide into more people. So the smaller the cross-sectional area, the greater the resistance. So hopefully you can see how these two factors can affect that. And then finally, the resistivity of the material, which is just an inherent factor that you can't really change. If a material was more resistive, that means the resistance is going to increase. If it was a material with a low resistivity, then that would mean that it's easier to travel through. So I just wanted to mention that those simulations, this video is not sponsored or anything, but they're really useful to really help visualize the physics concepts, and they're all free. So try and look at like animations that really bring to life the physics. Now let's look at the next part. Why do ammeters have low resistance? This is a common exam question. And the main purpose for it to have a low resistance is so that it can measure the maximum current in the circuit. If there's a sense of resistance, then the current it measures will be very limited. It won't be the fullest maximum current that it can have. The next question would be, why do voltmeters have very high or infinite resistance? And the reason why they have infinite resistance is because voltmeters want to draw as little current as possible, because they're trying to measure the actual potential difference between 2 points, and it doesn't want to get influenced by the current. So key things to remember: ammeters have very low resistance and voltmeters have infinite resistance. Thank you so much for watching. If you found this video helpful, then feel free to subscribe for any of the following subjects on the left-hand side for your A-levels. And if you know anyone doing GCSEs, then share this resource to them because I do those subjects on the right as well. Thank you so much for watching and all the best in your exams.